An ant feels nothing. No fear, no joy, no grief, no pain. That's the official story. For 300 years, science told us exactly what an ant is. A machine. A wind-up toy made of chemistry. 6 legs and a fistful of reflexes running the same hardwired code its ancestors ran 100 million years ago. It does not love its sisters. It does not mourn its dead. It cannot suffer, because there is no one inside to suffer. It is a robot built of meat. Except, in a lab in London, a bee that was attacked hours ago is now hallucinating monsters that aren't there. In a cage in Tokyo, an ant is performing surgery, biting off the infected leg of a wounded sister to save her life. In the desert, an ant injected with a single chemical overrides its own terror of being cooked alive and sprints into 60-degree sand. And under a microscope, a defeated cricket sinks into something that looks, smells, and behaves exactly like clinical depression, and a dose of antidepressants pulls it back out. These are not the actions of a machine. So here is the question that is currently splitting biology in half. When an ant fights, flees, plays, or carries its dead to the grave, is anybody actually home? Is there a flicker of feeling inside that pinhead brain? Or are we just projecting our own hearts onto a bag of chemicals? For the first time in history, we finally have the tools to look inside. And what scientists are finding does not fit the story we were told. Before we go any further, we have to be honest about a trap. 2 traps, actually. The first is seeing a face where there is none. Looking at an ant dragging a dead body and deciding it must feel grief. Simply because we would. Scientists call this anthropomorphism, and it has ruined more careers than bad data ever could. The second trap is the opposite, and it's just as dangerous. Deciding that because an ant is small, it must be empty. That nothing complex could ever happen inside a brain you can barely see. So researchers split the difference with cold, careful language. An emotion to a biologist is not a feeling. It's a function. It's a physical state, triggered by something in the world, that reshapes the body and the brain to survive the next few seconds. A surge of chemistry that says run, or fight, or grab the food now. Crucially, that state can exist with nobody consciously feeling it at all. A feeling, the actual sensation, the what it's like to be afraid, is the deeper mystery. That's the part we may never crack. But here's the breakthrough. Scientists realize they don't need to read an ant's mind to test for an emotional state. They just need 3 fingerprints. Does the state persist after the trigger is gone? Does it spread, bleeding into how the animal reacts to brand new situations? And does it bias the animal's judgment, tilting it toward optimism or dread? A reflex can't do any of that. A reflex ends the instant the stimulus ends. So if an ant carries fear with it long after the threat is gone, if a bad day makes it pessimistic about a totally unrelated choice, then whatever is happening in there is not a reflex. It's something far more interesting. Let's go hunting for those fingerprints. Start with fear, because fear is the oldest emotion of all. In a lab run by Professor Lars Chitka, scientists rigged flowers with a cruel little trap, a mechanical pincer that mimicked the ambush of a crab spider, snatching at bees as they landed. The bees survived. They escaped. The danger was over, but their minds did not get the message. Hours later, those same bees approached perfectly safe flowers. Flowers with no spider, no threat, nothing, and froze. They inspected them. They hovered. And then, again and again, they fled. They were rejecting good food and safe ground because their tiny brains were still bracing for an attack that had already happened. In the cold language of the lab, they were throwing false alarms. In plain English, a bee, hours after a brush with death, was still so gripped by fear that it was seeing monsters that weren't there. That is not a reflex. A reflex would have switched off the moment the spider was gone. This was a state that persisted, that spread to new flowers, that biased the bee toward dread. 3 fingerprints, all present. And if a bee's brain can hold on to fear like a scar, bees and ants are cousins, branches of the same ancient family tree, then we have to ask what an ant is carrying around after its worst day. If they can feel fear, can they break? Meet the male cricket. His whole identity is the fight, territorial duels, song, dominance. But take a cricket and let him lose. Again and again and again. Something in him collapses. The defeated cricket stops fighting entirely. He shrinks from every confrontation. A once aggressive warrior becomes a coward who flees from shadows. It looks like surrender. It looks, frankly, like depression. And here is the part that should stop you cold. When researchers gave these broken crickets drugs that alter serotonin, the same neurochemical family our own antidepressants target, the crickets recovered. The warrior came back. You cannot cure a software glitch with antidepressants. You can only treat a state, a mood. And it gets stranger. Take male fruit flies and repeatedly deny them mating. Let them be rejected over and over by uninterested females. The stress rewires their brain chemistry. And these rejected, frustrated flies start doing something disturbingly familiar. They walk right past clean food and deliberately seek out alcohol. They self-medicate. A heartbreak in an insect that ends at the bottom of a bottle. Persistence, generalization, a chemical state you can push an animal into and pull it back out of. The fingerprints keep showing up, and we haven't even reached the ants yet. Now, finally, the ant itself, and the most elegant experiment of them all, the black garden ant, Lasius niger, the same ordinary ant marching across your patio. Scientists trained these ants to learn two smells, one that meant reward, one that meant nothing. Then they offered a third smell, an ambiguous blend, halfway between the two. A glass half full, glass half empty test. Would the ant gamble on the unknown, or treat it as a waste of time? Left alone, the ants were natural optimists. Around 2/3 of them approached the ambiguous smell as if it might be good news. But then, researchers changed their day. Give an ant a surprise hit of sugar, an unexpected jackpot, and its optimism surged. It became a high-stakes gambler, betting on the unknown 3 times out of 4, and give it a small, nasty shock instead. The optimism collapsed into pessimism. The same ambiguous smell now read as a threat. Let that sink in. A good experience made an ant expect good things from an unrelated situation. A bad experience made it expect the worst. That is the textbook definition of a mood-biasing judgment. The exact thing that happens in your brain after a great morning or a terrible one. In an animal with a brain the size of a grain of salt. Fear, despair, optimism, and now the hot one, anger. In redwood ants, scientists did something almost unsettling. They injected aggression directly into the brain. A dose of dopamine, and the ants erupted into threat displays, jaws flung wide, bodies raised, daring any rival to come closer. A dose of serotonin, and the behavior shifted into something else entirely. Not threats, but full physical combat. Grappling, biting, war. 2 different chemicals, 2 different flavors of rage, written in code. This is the discovery that quietly demolishes the just a robot argument. Because rage in an ant isn't random, and it isn't purely mechanical clockwork. It runs on the same neurochemical dials that run rage in you. Dopamine, serotonin, the ancient machinery of emotion didn't appear with mammals. It was already here, humming inside an insect, hundreds of millions of years before the first human ever clenched a fist. But a dark question hangs over all of this. Maybe insects can only feel bad things. Fear, stress, rage, the grim survival emotions. Maybe there's no upside in there at all. So scientists asked an almost absurd question. Do bumblebees play? They gave bees tiny wooden balls. No reward attached, no food, no reason to touch them. And the bees rolled them anyway. Over and over, one bee rolled a ball more than 100 times, going out of their way, off the clock, for nothing but the act itself. Younger bees played the most, exactly like puppies and human children do. Older, working bees largely ignored the toys. And then the clincher. When the balls were taken away, the bees showed a lasting preference for the room where they'd played, returning to the color of the chamber that meant fun. They remembered the joy. They wanted it back. That is play, not a reflex, not survival, pleasure for its own sake, an intrinsically good experience, in a brain we were told could never have one. If a bee can feel something like joy, the ceiling we put on the insect mind was always far, far too low. Which brings us to the most haunting evidence of all. Not what ants feel about themselves, but what they seem to do for each other. In the colonies of Florida carpenter ants, when a sister is wounded on the thigh, the others don't abandon her. They operate. A nestmate clamps down on the injured leg and chews, slowly, deliberately, for over 40 minutes, gnawing through the exoskeleton to amputate the limb before infection can spread. And it works. Survival rates after these amputations hit 90% and above. Even more chilling, the ants diagnose. A wound lower down the leg, where amputation wouldn't help in time, gets a different treatment. Intensive cleaning instead of surgery. They choose the right operation for the right injury. The scientist who discovered this, Dr. Eric Frank, put it bluntly, the only medical system on Earth that rivals it is our own. And throughout that 40-minute ordeal, the patient lies still, cooperative, holding her own body up to give the surgeon access, as if she understands. Then there are the matabele ants, who hunt termites and lose limbs in the raids. The wounded release a chemical cry for help, and their sisters carry them home, pull the enemies off them, and lick antimicrobial medicine into the wounds. 90% return to active duty. Researchers who study ant rescue call it proto-empathic behavior, possibly the faint evolutionary beginning of the very thing we call empathy in ourselves. Reflexes do not run a hospital. But how? How does any of this fit inside a head smaller than a poppy seed? Your brain has 86 billion neurons. A honeybee has about 1 million. A fruit fly, 250,000. By that math, an insect brain should be hopelessly outgunned. Except brains don't work like buckets. They work like wiring. At the center of the insect brain sit two dense structures called the mushroom bodies, packed with thousands of intricately branched cells that integrate everything the animal senses, remembers, and feels. It's a processor, not a sponge, and it runs on a handful of chemicals you already know by name: dopamine, reward, drive, the override switch for fear; serotonin, stress, sleep, the gatekeeper of fight or flight; octopamine, the insect version of adrenaline, priming the senses for high stakes; and tyramine, tuning the baseline hum. These are not exotic alien molecules. They are the same neurochemicals orchestrating your emotions right now, as you watch this. Evolution wrote the chemistry of feeling once, deep in the past, and then never threw it away. The ant and the human are running different hardware, but underneath, it's the same ancient operating system. Now, in fairness, not everyone is convinced, and their best argument is genuinely unsettling. In the 1950s, the legendary biologist E.O. Wilson ran an experiment that still echoes today. When an ant dies, its body slowly releases a chemical called oleic acid, the unmistakable scent of death. So Wilson took that single chemical and painted it onto a perfectly healthy, living ant. Instantly, her sisters seized her. They carried her, kicking, struggling, alive, to the colony's graveyard and dumped her on the pile of corpses. She ran back. They carried her out again, and again, over and over, until the chemical finally wore off. To her family, she wasn't a sister fighting to live. She was just a smell that said dead. No grief, no assessment, no mercy, just a chemical key turning a hardwired lock. The skeptics, scientists like Brian Key, point to this and say, that's all of it. All the surgery, the rescue, the apparent care, just elaborate chemistry firing automatically, with nobody home. They point to the box jellyfish, which hunts and navigates with 24 eyes and no brain at all, as proof that complex behavior needs no inner life whatsoever. It's a powerful argument, and any honest look has to put it on the table. Some of what looks like emotion almost certainly is just chemistry on autopilot. But here's the problem with using that to dismiss everything. A chemical reflex ends when the chemical ends. It cannot persist for hours after the threat is gone. It cannot bleed into a totally unrelated decision. It cannot be lifted by an antidepressant. It cannot remember a room where it once felt good and choose to return. And yet, across bees, flies, crickets, and ants, that is exactly what scientists keep finding. Not every behavior is a feeling, but the evidence has crossed a line that pure reflex simply cannot explain. The scientific world is starting to agree. In April 2024, a group of the planet's leading minds on consciousness signed something called the New York Declaration on Animal Consciousness. Its claim was historic and carefully worded. There is now a realistic possibility of conscious experience not just in mammals and birds, but in invertebrates, in octopuses, in crabs, in bees, in flies. And they added one more line that changes everything. We should not wait for absolute proof before we take the welfare of these creatures seriously. That matters, urgently, because right now, humanity farms hundreds of billions of insects every year, in conditions no one designed with feeling in mind. If even a fraction of what we've just seen is real, if there is the faintest spark of suffering inside those bodies, then the scale of it is almost too large to think about. So, an ant feels nothing. That was the story, a robot of meat. No fear, no joy, no grief, no pain. But the bee still trembles at flowers that are perfectly safe. The cricket sinks into a darkness that antidepressants can lift. The garden ant turns optimistic after a sweet surprise. The young bee plays for no reason but the joy of it. And the carpenter ant chews for 40 patient minutes to save a sister's life. We may never know, truly know, what it is like to be an ant. That door may be closed to us forever. But the barrier was never their simplicity. The barrier was our imagination. For 300 years, we couldn't picture a mind that looked nothing like our own. We're only now learning to look. So I'll leave the verdict with you. Look at everything we've seen. The fear, the despair, the optimism, the rage, the play, the care. Be honest with yourself. Do you think there's something it feels like to be an ant? Or are we just seeing our own reflection in the chemistry? Tell me in the comments. I read them. And I genuinely want to know which way you land. Because right now, the smartest people on Earth can't agree either.